Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. The contract ended 6 months ago, and his username still opens every production bucket. That username is an IAM user, a long-term identity nobody thought to remove. AWS Identity and Access Management, IAM, is the control plane that stops exactly this. Who can touch what? And this is the first video in our AWS Cloud Practitioner IAM series. By the end of this video, you will be able to explain the difference between IAM users, groups, roles, and policies. You'll read a JSON IAM policy and spot a least privilege violation. And you'll attach permissions through groups in the AWS console instead of per user. AWS Identity and Access Management, IAM for short, controls who can do what on which AWS resource. Think of it like a building access system. Your badge proves who you are, and a separate key card decides which doors open. In IAM, the principal, that's the user or service making the request, authenticates first. Then, IAM checks authorization, and only then does the resource allow the action. Authentication asks, "Who are you?" That's a username and password, maybe a multi-factor authentication code, an MFA code from your phone. Authorization asks, "What can you do?" That's where IAM policies come in. Here's the beginner trap. Logging in successfully does not mean you can access anything. A brand new IAM identity starts with 0 permissions. Access has to be granted explicitly. An IAM user is a long-term identity inside an AWS account. It can have console credentials, programmatic access credentials, or both, depending on how it's configured. But here's an important modern AWS security lesson. Just because IAM users exist doesn't mean you should create one for every employee or application. For workforce access, organizations commonly use federation through AWS IAM Identity Center, so employees can use centralized identities and temporary access. For AWS workloads, roles are usually preferred because they provide temporary credentials instead of long-lived access keys. IAM users still matter, and you'll absolutely encounter them in AWS environments and on certification exams. So remember the distinction. IAM users are long-term identities. Roles provide temporary credentials when they're assumed. And whenever possible, design your environment to minimize long-lived credentials. Let's create an IAM user so you can see how the user, group, and policy model works. One important warning first. We're creating this IAM user as a learning exercise. For workforce access in a modern organization, you should also evaluate federation through AWS IAM Identity Center, instead of automatically creating long-lived IAM users for every employee. Now open the IAM console. Choose Users and start creating a user. We'll call ours Michael Scott. If you're following this in a sandbox, configure only the access required for the exercise. Don't attach broad permissions yet. We're going to assign permissions through a group in a moment. That gives us a clean way to see the relationship: user, group, policy, permission. And when you're finished with the lab, remove any identities or credentials you no longer need. Before we move on, remember the default. A brand new IAM user with no policies attached can do absolutely nothing. That's default deny in action. A group is simply a container for IAM users. You attach a policy to the group, and every member inherits those permissions. The pattern you'll see in production: developers, read-only auditors, and billing. One policy, many users, and way less clicking for you. IAM groups make permissions easier to manage, but there are a few rules you need to remember. First, attach common permissions to groups instead of repeatedly attaching the same policy directly to individual users. Second, if someone no longer needs the permissions provided by a group, remove that user from the group. But be precise about what that means. Removing someone from a group removes the permissions they inherited from that group. It doesn't guarantee the user has no access. The user could still receive permissions from another group or from policies attached directly to that identity. Third, IAM groups cannot be nested inside other IAM groups. And fourth, one IAM user can belong to multiple groups. So if Dave belongs to developers and read-only auditors, his effective permissions can come from both. Groups make administration easier, but when troubleshooting access, always look at the identity's complete permission picture, not just one group. A role is a temporary identity that any allowed principal can assume. It has no permanent credentials. Instead, AWS Security Token Service issues short-lived credentials when the role is needed. Picture an EC2 instance that has to read from S3. You don't hard-code long-term keys on that box. You give the instance a role, and it borrows permissions on demand. Here's the simplest way to separate IAM users from IAM roles. An IAM user is a long-term identity. A role is an identity that trusted principals can assume to receive temporary credentials. Suppose an application running on EC2 needs to read objects from S3. You could create long-lived access keys and place them on the server. Don't make that your default design. Instead, you can assign the EC2 workload a role with the permissions it needs. AWS can then provide temporary credentials for that role without you hard-coding permanent keys into the application. Temporary credentials reduce risk because they expire. But don't misunderstand what that means. If temporary credentials are stolen while they're still valid, an attacker may be able to use whatever permissions those credentials provide. Expiration reduces the exposure window. It does not eliminate the need for least privilege. That's why roles and least privilege work together. Use temporary credentials whenever practical. Then make sure those temporary credentials can do only what the workload actually requires. Quick checkpoint. An application running on an EC2 instance needs permission to read objects from an S3 bucket. Should you hard-code an IAM user's long-lived access key into the application? Or should the workload use an IAM role? The better design is the IAM role. For EC2, you associate the appropriate role with the instance, so the workload can obtain temporary credentials for the permissions it needs. Now remember the security principle behind the answer. It's not roles are magically secure. It's roles let workloads use temporary credentials instead of forcing you to distribute and manage long-lived access keys. Then you apply least privilege to the role itself. Temporary credentials plus narrowly scoped permissions. That's the pattern you want to remember. Here's the part of IAM that beginners need to respect. A tiny change in a policy can dramatically change what an identity is allowed to do. Wildcards are a perfect example. Suppose an S3 policy allows S3 pont get object. Now look at the resource. If you scope that permission to a specific object path, the permission can be narrowly targeted. Broaden the resource pattern with a wildcard, and that same action may suddenly apply to far more objects than you intended. Wildcards can also appear in actions. A narrowly defined action grants a specific capability. A much broader wildcard can grant an entire family of actions. That's why least privilege isn't just about whether the policy says, allow. You have to examine the combination of effect, action, resource, and, when applicable, condition. One wildcard in the wrong place can turn a narrow permission into a much broader grant. So let's stop thinking only in terms of console checkboxes and start reading the actual policy. This is a full IAM policy, and it's just JSON. Version tells AWS which policy language you're using. Statement wraps the actual rules. Effect says allow. Action names the exact API call, S3. GetObject, meaning download an object. Resource limits the grant to one bucket path. Together, those two lines are the entire permission boundary. 5 policy elements should immediately get your attention: version, effect, action, resource, and condition. Effect tells AWS whether the statement allows or denies something. Action defines which API operations the statement covers. Resource defines which AWS resources those actions apply to. And condition lets you place additional requirements on when the statement applies. For example, a condition might require a particular security context before access is allowed. An MFA-related condition can require the appropriate MFA context. Other conditions can evaluate different request characteristics depending on the AWS service and policy. The important point is that condition gives you another way to narrow access. Don't confuse these controls. MFA answers an authentication-related question. Network, source, resource, identity, and other policy conditions address different parts of the request context. The professional skill is learning to combine them instead of expecting one condition to solve every access control problem. Let's build the beginner mental model for IAM policy evaluation. Start with default deny. If nothing grants the requested action, the request is denied. Next, AWS evaluates the policies and controls that apply to the request. If an applicable policy contains an explicit deny for that request, that deny overrides an allow. That's the rule you need to remember. Explicit deny beats allow. But there's another important layer. AWS environments can use different policy types and permission guardrails. Identity-based policies can grant permissions. Resource-based policies can participate in access decisions. Permissions boundaries can limit the maximum permissions an identity can receive. And AWS organizations' service control policies can limit what identities and member accounts are allowed to do. So don't reduce production IAM troubleshooting to, I found an allow, therefore it should work. An allow may be necessary, but other applicable controls can still restrict the request. For the beginner exam-level mental model, remember, default deny starts the process. An applicable allow can grant access. An explicit deny overrides the allow. And broader permission guardrails can limit what identities are allowed to do. Next checkpoint. A user has an allow for S3 full access and a deny on the S3 delete object action. Can they delete objects? Pause. Then I'll reveal the answer. Least privilege means giving an identity only the permissions required to perform its job. But don't implement least privilege by randomly adding permissions every time an application throws an error. Start with a workload. What does it actually need to do? Which AWS service does it need to call? Which API actions are required? Which resources should those actions apply to? And can you narrow the permission further with conditions? Build the smallest practical policy from those requirements. Then validate it. Tools such as IAM Policy Simulator and IAM Access Analyzer can help you test and refine your design. If something fails, investigate the denied operation before expanding the policy. Don't automatically solve every access denied message by adding another wildcard. And don't begin with administrator access because it's convenient, and promise yourself you'll tighten it later. Start narrow. Test. Understand the failure. Then expand only when the workload genuinely requires it. That's least privilege as an engineering process, not just an exam definition. Policies don't all live in the same place. Identity-based policies attach to users, groups, or roles. They grant permissions to an identity. Resource-based policies attach directly to a resource, like an S3 bucket, and grant permissions to a principal named in the policy. Then you have permissions boundaries and service control policies, which set outer limits so no identity can ever exceed a ceiling. Know where each attaches and you'll stop confusing who gets what with where the policy lives. For humans at a company, a common security pattern is to connect the corporate directory to AWS IAM Identity Center instead of creating a separate IAM user for every employee. That lets workers sign in through the directory and get temporary access rather than long-term console passwords scattered across the account. This is a broadly accepted approach, but the exact session mechanics vary by configuration, so check the current AWS documentation before you commit. Quick checkpoint before we leave Identity Center. If a company is onboarding a new team, what's the recommended way to give employees AWS console access instead of creating a separate IAM user for every person? Pause and answer it. The right move is to federate them through AWS IAM Identity Center so each person assumes a role. Here's that same group flow from the command line. First, you'd run the create group command for a developers group. Then you'd attach a managed S3 read-only policy to that group using its policy ARN. And ARN means Amazon Resource Name, the unique identifier for that policy. Finally, you'd add Michael Scott to the developers group so he inherits whatever permissions the group has. Check the current AWS CLI docs for the exact flags and policy names before you run this. MFA adds another layer of protection to human authentication. And there's one identity that deserves special attention: the AWS account root user. The root user has extremely powerful account-level capabilities, so protect it carefully. Secure the root user's authentication, enable MFA using the options AWS currently supports, and don't use root for everyday administrative work. For normal workforce access, evaluate centralized access through AWS IAM Identity Center and your organization's identity provider. If human IAM users still exist in your environment, protect those identities appropriately as well. The bigger lesson is this: strong authentication and least privilege solve different problems. MFA helps protect authentication. Least privilege limits what an authenticated identity is allowed to do. You want both. Because even strongly authenticated users shouldn't automatically have unlimited permissions. Access keys deserve special attention because long-lived credentials can be copied, committed to source code, exposed in scripts, pasted into chat, or forgotten on a workstation. So the first question shouldn't be, how often should I rotate this access key? The better question is, Do I need a long-lived access key at all? For workloads running on AWS, prefer roles and temporary credentials when the service supports that pattern. For workforce and developer access, evaluate federated access and temporary credentials through solutions such as AWS IAM Identity Center. If long-lived access keys are genuinely required, protect them carefully. Never commit secret access keys to source control. Never paste them into tickets or chat messages. Remove credentials that are no longer required. Monitor their usage. And scope the associated permissions using least privilege. Credential rotation can still be part of credential management where appropriate. But don't create permanent credentials just so you can build a process for rotating permanent credentials. The stronger design is often, don't create the long-lived credential in the first place. To assume a role from the command line, you call the sts assume role command and give it the role ARN and a session name. The response includes an access key ID, a secret access key, a session token, and an expiration timestamp. That expiration is the whole point. These credentials are designed to be short-lived, so if they leak, their useful window is limited. Pop quiz on what we just ran. When you assume a role, which AWS service actually mints those short-lived credentials? Pause and name it. The answer is the AWS Security Token Service, STS for short. IAM isn't just something you memorize for an AWS certification exam. Identity and access management shows up across almost every serious cloud role. Cloud engineers use IAM when deploying workloads. DevOps and platform engineers use it when applications and pipelines need AWS access. Security engineers use it to enforce least privilege and investigate excessive permissions. Cloud architects use it when designing cross-account access, federation, workload identities, and security boundaries. And dedicated IAM engineers go even deeper into identity governance, federation, privileged access, automation, and compliance. That's why learning IAM has such a high return. You aren't learning one isolated AWS service. You're learning one of the fundamental security models behind cloud computing. If you can look at an architecture and answer, who is the principal? How do they authenticate? Which permissions do they receive? Which resources can they access? And what limits those permissions? You're starting to think like a cloud engineer instead of someone who only knows where the IAM button is. For the Cloud Practitioner exam, you don't need to write policies from memory. You need to recognize these facts fast. What users, groups, roles, and policies each do. What a least privilege scenario looks like. That roles give temporary credentials. That IAM is global even when the resources you're accessing are regional. And that root is not a daily driver. This week, create one group with a read-only policy in the free tier. That one console task locks in more than rereading nodes. Same platform, two very different security postures. Beginners use the root account for daily work, attach full admin to every user individually, and hardcode access keys. Pros, lock root with MFA, push permissions through groups, write least privilege policies, use roles for applications, and federate humans instead of piling up long-lived users. The difference isn't knowledge, it's the defaults you choose. Let's make the IAM model real with a small sandbox exercise. Open IAM and create a test group called Read Only. Attach an appropriate AWS-managed read-only policy for the service you're testing. Then create a test IAM user for this lab and place that user in the read-only group. Remember, we're using an IAM user here specifically to demonstrate the user-group policy relationship. Now sign in with the test identity. Perform an operation the policy is designed to allow. Then attempt an operation that should be denied. For example, if the identity is supposed to have read-only access, test an appropriate read operation and then attempt a write or delete operation that should fall outside that permission set. The exact console experience can depend on the service and policy you're testing, so focus on the authorization result rather than whether a particular console button appears. Then go back to IAM. Remove the user from the group. Test again. Now you've seen the complete relationship: user, group, policy, allowed action, denied action. And when you're finished, clean up the test identities and credentials you created. That's a much better IAM lesson than simply memorizing definitions. Here's the IAM request flow in one pass. A principal makes a request to AWS. Maybe it's Michael's IAM user. Maybe it's an application using temporary role credentials. AWS first determines the identity associated with the request and evaluates the relevant authorization context. Then, the applicable policies and permission controls are evaluated. Does the request have the permissions it needs? Does an explicit deny apply? Are there other controls restricting what the principal can do? The final result is either allowed or denied. Now bring observability into the picture. AWS CloudTrail records AWS API activity according to the event types and logging configuration in your environment. That distinction matters. Don't assume every possible operation will automatically appear in exactly the same way without considering CloudTrail configuration. For example, management activity and certain resource-level data activity can have different logging considerations. So when troubleshooting an authorization problem, use the information available from the failed request, IAM configuration, and relevant CloudTrail records to reconstruct what happened. Ask: who made the request? Which action did they attempt? Which resource were they targeting? What policies and controls applied? And what evidence can I use to determine why the request was denied? That's how IAM troubleshooting works in the real world. Full mental model checkpoint. Name the 4 building blocks of AWS IAM and the one rule that overrides everything. AWS gives you several tools that can help you evaluate and improve permissions. IAM Access Analyzer helps analyze access and policies so you can identify areas that deserve review. IAM Policy Simulator lets you test how policies evaluate specific actions and resources. Credential and access reports can help you review how IAM credentials are being used. And AWS also provides policy building and validation capabilities that can help you create and review IAM policies. But here's the professional lesson. A tool finding is evidence to investigate, not an automatic instruction to delete a permission. Suppose a permission hasn't been used recently. That might mean it's unnecessary. Or it might support a quarterly process that simply hasn't run yet. Before removing access, understand the workload and business requirement. Then make the permission smaller when the evidence supports doing so. Least privilege isn't delete everything that looks unused. It's continuously prove that every permission has a reason to exist. 3 takeaways to lock in from this whole video. First, users, groups, and roles are identities. Policies are the JSON permissions attached to them. Second, prefer roles and federation over long-lived IAM users. Third, apply least privilege from the start, and remember explicit deny always beats allow. If you can explain those 3 sentences to a coworker, you've got the core. Now that you understand users, groups, roles, policies, least privilege, and temporary credentials, the next step is understanding how those pieces work together in more advanced architectures. Next up, AWS IAM policies and trust relationships. We'll look at the difference between an identity-based policy and a resource-based policy. Then we'll open an IAM roles trust policy and answer one of the most important IAM questions. Who is actually allowed to assume this role? We'll also connect that to AWS Security Token Service and temporary credentials. And we'll look at why permissions attached to a role and the trust relationship for that role solve two different problems. One answers, who can assume me? The other answers, what can I do after I'm assumed? Once that distinction clicks, IAM roles become much easier to understand. And it prepares you for cross-account access, workload identities, CI/CD permissions, and real enterprise AWS architectures. Before that drops, do one thing. Enable MFA on your AWS root account and stop using root for daily work. Create an IAM user for yourself with just enough access, or go further and use IAM Identity Center. Then tell me in the comments, are you still creating one IAM user per person, or have you switched to Identity Center? Subscribe and I'll see you in the next part. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson. Build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.